Good afternoon and welcome to this new webinar from ERA, the European Union Agency for Railways. I'm Cyril Martin, Communication Officer, and I will be your moderator today. Today we will discuss human and organizational factors. And without further ado, I will now introduce our speakers very briefly. Joseph Doppelbauer, the Executive Director of ERA. Jane Yeo, Project Manager in the Safety and Operations Unit at ERA. Christine Mühl, Scientific Desk Officer, Human Factors at the German Center for Rail Traffic Research. Dr. Niels Brandenberger, Human Factors and Neuropsychology Specialist at German Aerospace Center. Clarisse Laguesse-Davoine, Project Officer in the Safety and Operations Unit at ERA. Fabrizio Carpinelli, Project Officer in the Safety and Operations Unit at ERA. And then, last but not least, Dr. Marcus Arrhenius, Safety Expert at DB NITS. Thanks to all of you for being here with us today. Before I give the floor to Joseph Doppelbauer, I'd like to remind you that, as usual, you are most welcome to ask questions to our speakers using the chat function, which you will find at the top right-hand corner of your screen. You can also tag questions from other attendees, which you judge valuable by clicking the sub icon. We will do our best to reply to the greatest number of questions at the end of this webinar. A last word to say that this event is being recorded and will be available on our YouTube channel and in our website in the coming days. Without further ado, I will now give the floor to Joseph Doppelbauer, the Executive Director of the agency. Unfortunately, Joseph couldn't with us today, so he recorded a message for us. Please, Joseph.
Merci, Cyril. Good afternoon, ladies and gentlemen. Welcome to our webinar on automation in railways. We know that the potential of automation in railways includes optimization of normal operations. Highly reliable automation can optimize the operation so that capacity and performance are improved under routine operations, while also ensuring consistency and improving safety. Global optimization. Automation can consider a broader range of variables than a human operator and so provide for optimization over a larger area. Standardization of rules. Automation can drive the standardization of rules and provide a business case for investment to remove unnecessary variation in the railway. And in regard to staffing, reliable automation can reduce operator workload and allow for a smaller workforce. It is a myth, however, to think that automation will eliminate humans from the socio-economic technical system in railways. The human contribution is not removed, but rather moved from the operational to a different level. Design, supervision of the system, maintenance, certification, and regulation. Automation changes the tasks and role of the humans in the system, but it does not remove them. The integration of human and organizational factors, HOF, will still be necessary. Railway automation is happening, and only through integration of HOF by all stakeholders can it reach its full potential. I'm very happy that today the German Center for Railway Research, DZSF, will also contribute to our webinar aimed at busting several myths related to railway automation. I'm now handing over to Jane Yeo, who will describe what ERA is doing in this context.
Hello, my name is Jane Yeo, and I'm the project officer for the Human and Organisational Factors, or HOF as we call it, work here at the agency. As you've just heard, automation in railways has great potential. However, as in so many areas of our life nowadays, we have to sort out the fact from fiction. There are many assumptions or myths about what automation can and cannot do, and these myths need to be debunked or busted for automation to reach its full potential. To give you an example of a myth, automation never fails, but I'd ask you to reflect on how many times the automatic checkouts found in so many supermarkets today have failed with you. In the railway world, a common myth is that train drivers can switch easily between automated and non-automated tasks with no negative effects, but this is not the case. In order to dispel these automation myths, ERA has developed, in collaboration with DZSF, the German Center for Rail Traffic Research, we're publishing in both English and German a series of easily understandable yet scientifically sound evidence-based papers dispelling the myths of automation and showing that humans still have to be taken into account by integrating HOF. In doing so, not only are risks to safety performance minimized, but performance overall can be optimized. I'm pleased to welcome the authors of the first two papers here today, Kristin Mühl and Dr. Niels Brandenberger, followed by my ERA colleagues Clarisse Laguez-Davoine and Fabrizio Carpinelli, who will tell you about the HOF in Change Management Toolkit they've developed with input from the sector. And last but not least, Dr. Marcus Arrhenius from DB Nets, who helped develop and test the toolkit and who will tell us about their experience and how the toolkit was adapted as a result. So without further ado, over to you, Kristin.
Perfect. Thank you, Jane. Okay, great. Thank you, Jane. Yeah, hello everyone. I'm quite happy to be here and happy to give you some insights. I think it was or has been 1 year ago when I met Jane online, and we were talking about the idea of this automation myth-busting series, or she talked about it and got me on board. And well, now we are already preparing, or the third paper is already prepared. So I'm happy to talk about this topic today here. As you maybe heard, my name is Christine Mühl. I'm a researcher, a scientist at the German Center for Rail Traffic Research, which is a governmental research unit. And my focus is on human factors. I'm a psychologist and made my master's degree in human factors and my PhD also in the context of human factors, anticipation, and situation awareness. Next slide, please. So this is why I also was quite interested in addressing the first myth, which is situational awareness remains the same, no need for additional information. I will, of course, take a closer look now on this myth, and I would like to show how automated railway can operate as usual and what kind of best practices exist to keep a high situational awareness. Next, please. Yes. With all the myth-busting series, we actually started with a daily example. And I used one you are maybe familiar with, a robot vacuum cleaner, those little automated helpers that keep the dust off us, which are quite nice, which work really, really nice. And I mean, it's an automated system. And in best case, it works good. But there also might be problems or kind of fails. For instance, please, could you push to the next? Yes, thank you. Maybe you have seen some pictures where there have been a broken robot down on the stairs, or maybe a line with a brown trail in the flat. In best case, it would be out of moist soil. Well, there are some troubles, and there can be some troubles with this automated systems. They are kind of annoying, but in this case, luckily, they are not safety critical. And the question is actually, what was the problem? Why did it work out? So what did the human and the automation made or did not made? Please go to the next, and then even the next. Yeah, the next, please, also. The problem is, or the aspect is, that we actually need to know what the automation is doing. So we need to know the limits, we need to know the skills, and we need to anticipate how it will work in the future in order to have a good kind of, you could say, collaboration that everything works fine. So we need to have a high situation awareness. That is actually the part or the relevant aspect. Please come to the next slide. There I have a model, next one, of situation awareness, which is kind of quite well known. It's from Mika Entley, and she proposed that situation awareness exists on 3 levels. It's first the perception of elements in the current situation that we as humans need to perceive. We need to comprehend it. That means we need to take or bring them together with our pre-knowledge. And based on this situation model, which has been developed, we can project what is going on, what will be in the future. And if we have a good situation awareness, we can have or make good decisions and good actions. And this is actually the preconception for good action and decisions. And of course, there are factors that influence this process, like individual factors, goals, objectives, experience, training, preconceptions, abilities, and also task and system factors like the system capability, interface design, stress and workload, complexity, or also automation. So it seems like automation might affect this process of situation awareness. Situation awareness has also been addressed in Wales so far. So, for instance, please could you turn next? in understanding signaling and control in rail operations, in train driving, or also in rail maintenance track work. So it is a concept that is also relevant, definitely, for rail traffic. Taking a closer look on the levels of automation, I think if we are familiar with rail traffic and automation on rail, then the grades of automation, the GOA, are quite familiar for you. So the highest level would be GOA 4, unattended train operation. However, there exist far more differentiations of levels of automation. One which is quite famous is the one of Sheridan for Planck and Parasuraman, which developed different levels of automation related to the human information processing. So it is, it has 10 steps or levels. First, the one is that the system offers no assistance. The human must take all decisions and actions. For example, 5 is the system executes that suggestions if the human improves, and the highest level 10 would be that the system decides everything, acts autonomously, and ignores the human. So the human has nothing to do, cannot intervene, and we have a quite larger differentiation on that. Moreover, information processing is not just seeing the information, it's much more. It's information acquisition, information analysis, decision and selection, action implementation. And so we can have all these these 10 levels for the different kind of information processing. So a system might be quite highly automated in information acquisition, but has a low level of automation, for example, in action implementation. So systems or automation, automated systems can definitely vary. And this is important if we take a look on the combination of levels of automation or the effect of automation on situation awareness. Next slide, please. Because if, as we know, it is important to have good situation awareness in order to have good decisions and good performance. But if you have a system which takes over a lot of aspects on information acquisition, it is harder to understand for the human or to perceive the relevant elements for the human if there's not any kind of support, some kind of interface that provides all the information that the technology has to the human. And also the same with information analysis, which affects the comprehension and the projection in the context of situational awareness. If it's taken by the machine, then it's really hard for the human to understand what is going on, what the machine is doing, if it is not displayed back to the human. So automation definitely affects situation awareness, and we can also take a closer look on how it is affected, but this would be maybe now a bit too deep for now. Please, the next slide. Of course, brought some examples that where you can maybe see or get more insights on that. So there already exist some good interfaces in railway. For example, the DMI, the driver machine interface, which has been developed also with human factors experts for the ETCS. And what we can see here on the DMI is that it's used for GOA 2, so information acquisition and information analysis is supported. Information acquisition because we get here some information like the speed, sealing speed, but also the target speed. So there we have the B, the speed control. If you are over speed, there will be a little orange line. It's shown for the drivers. And you also have braking target points. Please go to the next, then yes, and next one also, then we can see it. We have also information on the information. We have also further information or kind of automation of information analysis, because people get a braking curve. So if there will be a stopping point, which will be shown in the D planning part, then in the speed control, there will be kind of colored yellow line, which shows how I have to reduce my speed in order to brake at this point. So this kind of braking curve. We also have a speed control and, of course, also a warning, which helps drivers to drive optimally. So what we can say is that the DMI supports this kind of anticipatory driving. It supports situation awareness. I got a lot of information here that I should or had to get out of the train, like with all the signals, if I wouldn't have it here in the DMI. So this is quite nice. But with a higher level of automation, it might also lead to a reduction in specific practical and theoretical knowledge of operators. Like, does the train driver then know really when he had to brake if he wouldn't have this support? So if then he should have should drive manually again, this would be maybe a bit harder for him. Please, on next slide, I also have a second example. Of course, we also have higher levels of automation in railway. The automated metros or driverless metros with GOA 4. And there we have some kind of challenges of information acquisition and analysis in the support center, where they are kind of supervised. They only get information via screens, so they don't have acoustic or haptic information that a train driver maybe would have, but they maybe have also more sensor information, more screens, more details they could take a closer look at. But if there are troubles, we have here the problem of the out-of-the-loop phenomenon, which means that, or which is the major consequence of automation and leaves the operator to be kind of a bit handicapped in their ability to take over manual operations, because there's kind of a loss of skills or loss of situation awareness. And it is really hard to keep the situation awareness, but it's really necessary to keep situation awareness in case if there will be any troubles. So my last slide, please. In order to have the operation as usual, we know that we need to have an adequate situation awareness. And this is changing with automation. So in order to enhance this, we need human-centered information and task design. We need training. We need to take the human in the focus. And this is actually also the last sentence I have here, or this was also the last sentence in the paper. The key is putting people at the heart and not underestimating the complexity of human organizational factors that influence performance in a socio-technical system. And this is what also the ERA wants, I think, with the HOF topic, and also we as a DZSF. And also I know my dear colleague Nils Brandenburger from the DLR. They are doing a lot of nice research on that. And so I'm quite happy now to hand over to him. Thank you. And Nils, it's your turn now.
Yeah, thank you. Thanks a lot, everybody. And thanks, Christine, for the nice introduction and your interesting talk. Please go one slide further already. That's exactly, here we are. That's about the second myth, actually. Yeah. And I'd like to take the opportunity here to walk you through, or a little through, the research we've been doing at the DLR in the recent years that led us to the conclusion, or also empirically found the conclusion, that actually humans are at the heart also at automated railway operation. Yeah, next slide, please. I'd like to elaborate on this a little. Just to give you a quick heads up, or from our perspective, now railway automation actually is picking up pace, mainly due to the fact that operating companies now see that automation is the key element in order to increase transport capacity while at the same time reducing energy on the main line, which is in line with the overall European transport strategy. And as we are picking up pace in this automation development, and also going forward there on this path, actually for us the most interesting part of this path comes into vision, which is the fallback layers and the question, what happens if automation goes wrong? And we need to have a valid answer to this, for sure. in order to at least have three things done, which is, first of all, well, we want to remain safe and want the transport to remain safe. That's the most important one. But on the other hand, we also actually want to harvest the envisioned capacity gains, because otherwise there would be no use in automating at all. And thirdly, of course, if we are trying to introduce a new technology, we have to think about homologation and approval. So that is also a key aspect why the fallback layer is so important to us. Next slide, please. Traditionally, like now from a HOF perspective, because that's what we're talking about, like taking the human organizational perspective, and Christine has already touched upon this, we think about, or you stumble across the grades of automation taxonomy, which basically tells you, well, stepwise or subsequently, we are going to automate several tasks that are needed for railway service, subsequently from the human to the automation technology. And I'd like to phrase this a little bit sarcastically, until everything is done and we don't have to touch it again. Well, that would be nice, but is this really the way that is realistic, and also from a human and organizational point of view, the most desirable? Because, I mean, we have to take an holistic approach here and consider a lot of factors. For example, we have to take the operational perspective and think about, do we have, or are we incorporating a swift mitigation process when we are automating from 0 to 100%? Also, we have to take the economic perspective and think about, is this the best way of deploying, like researching, developing and deploying automation technology from an economic return on investment point of view? Do we really have to go that far to 100%? Because obviously that impacts the funding. Also, like I already touched upon the safety consideration point, we definitely have to think about safety, fallback layers and resilience. And also there is the question, do we really need 100% automation? Can we even achieve the capability, automatic capability, to catch every corner case that might occur and hard code basically this into automation technology? And then last but not least, we should think about staff or occupational satisfaction. And actually, we've been thinking about this for quite a while now. Next slide. On the next slide, I try to depict quickly the broad areas that are at least needed, at least those, probably they are not exclusive and there are more, but those ones are at least needed to gain a holistic picture of what automation actually needs to incorporate in the fallback layer in order to come up with a sound vision of GeoF 4.3 operation on the main line. So basically on the x-axis you have the time since 2015, because that's when we started basically looking into this GOA 3.4 topic. And on the y-axis you have the kind of a maturity level. And of course, well, human factors, human organizational factors. So task analysis, what kind of tasks are being done by the human, at which grade of automation, deducting user requirements, testing this, user performance metrics, fatigue metrics, workload metrics. All this is important in order to come up with workstation design, HMI design, what kind of information is being displayed, which is also then which is relating to the situational awareness topic we just had in the first talk. Then also like interaction analysis. I mean, the operating company is interacting with the infrastructure side, so you have all kinds of signaler driver interaction. How does this develop in the future? How do they communicate? This touches upon the whole FMRCS topic, like what comes after GSMR basically, and do we have enough broadband to go for remote control, link trains via video feeds and sending control commands over a wide physical gap, so to speak. So this is interesting areas that we are researching at the moment, which are also covered by current projects to come up with operational performance metrics. Like, I mean, we are looking to invest and also deploy this technology. How can we anticipate the probable gains in terms of capacity and so forth? So we need to develop KPIs, and all this is needed to iteratively look at it, and in the end to deduct a sound and operational vision how could GeoF 3.4 look like on the main line, the operation, the service, and while doing that, we also developed the one vision that I'd like to share with you today, and which is also being deployed at the moment in another project, which looks more into like with a higher maturity level, which looks more into the like a test trial, not only field test, like testing it once or twice, but testing it over a period of 1 year in a mixed traffic freight service operation context. That is being done at the moment, which, for example, then also brings the question of standardization. So you can already see that it's going more towards regular service, because then it's about interoperability between suppliers. And so this is also stuff that needs to be taken into account when thinking about a holistic vision for the GeoR 3.4 on the main line. Next slide, please. So I'd like to come back to those, like I asked or raised the question, like, is this really the best way of doing so? And I touched upon a couple of subjects to be considered, and I'd like to answer what, after all this research that we've been done, is our impression, what would be most suitable. Yeah? And in terms of the operational readiness to disruption, we tend to think that the human staff remains a key agent in the, like, for knowledge, decision making, and communication. That would be wise to do. In terms of economic consideration, we think that training and like an expert staff is probably also more economically more reasonable than trying to hard code every corner case and every possible system state into an automation technology. Maybe it's doable. I think even that can be doubted by someone, but even if it is doable, it's probably pretty expensive. So having a well-trained staff probably is the wiser way to go forward. And this is the next one, actually, when it comes to the regulatory approval topic, actually is really nice, because sometimes I have the feeling that the human factor is a kind of connotated in a, oh, that's something we have to mitigate. Yeah, that's a bad thing. We have to mitigate it. But I think actually it's the other way around when it comes to GeoR 3.4. Because here, actually, the human factor is saving the day, because we have these difficult situations, disruptions that need to be mitigated. And it's very difficult to do this with automation technology. So actually, the human staff, well trained and so forth, is actually saving the day. That's our impression here, due to this fallback layer. Yeah, and also in terms of occupational satisfaction, providing a meaningful role for staff, yeah, in the future is actually eliciting, and we have some empirical data on this as well, eliciting a positive outlook, yeah, instead of occupational worries that you do encounter when talking about automation and the process of railway automation with a regular train driver today. Next slide, please. Thanks. So basically, we came up with this vision, like considering everything that I just mentioned, also in the graphical display. Putting this together, we came up with the vision that a GeoR 3.4 on the main line, as a fallback layer, like in routine operation, it's automated, it works, that's nice. But then at some point, when it comes to the fallback layers, you should have a human remote control and recovery layer where disruptions can basically be mitigated by an expert team being situated like physically distant, but and somehow centralized in order to put the service back on track, so to speak. Yeah. So in case there is a problem, you should have a trained troubleshooting team, so to speak, ready to mitigate the problem. And that basically is the definition of human-machine collaboration. Next slide, please. I tried to, there's a lot of psychological theory around, and I tried to really simplify this into a chain of layered effects, which is depicted, well, on the left bottom. And the key message of this chain of effects is actually that former constructs affect the latter ones. So you have a chain like from task characteristics, task load, over workload, effort, fatigue, performance. Now we are talking about the single operator in this case. And what you do at the former levels or constructs actually impacts all subsequent ones. I put down some empirical evidence on the right, and I will come to this in 1 second. But firstly, I'd like to point out the two main messages, which is basically get the start right. Yeah. And once you get the start right, the task characteristics, the task load, not too much, not too many, yeah, tasks. Get the workload balanced right. These are the key aspects, because then the subsequent constructs, workload, effort, fatigue, performance, will follow accordingly. And this is also what's being depicted on the right here, just to give you an impression of what is depicted. For example, if you look, you have dotted lines, which is what you would expect from theory, so the hypothesized effect, and you do have solid lines, which are basically the observed empirical values. On the x-axis, you have ascending grades of automation. And on the y-axis, you have relative prevalence of this construct, yeah, from very low to intermediate to very high. And I just walk you through the one, for example, if you take the workload, we'd expect that from GOR1 to GOR2, workload is dropping further into the underload spectrum. And this is actually also what we observed in our simulator experiments. And with this, the subsequent constructs like fatigue actually follow according to theory. So if you look at the fatigue line, you'd expect an increase in fatigue, and that's actually what we observed, with negative performance consequences, because higher fatigue leads to more or to worse performance. And if you go further from GR2 to 3, you can actually see that it's possible to turn this around a little by heightening the workload, because you have a lot of flexibility now, because you have it's not bound one operator, one train, but you can actually manipulate the number of trains. So you can actually manipulate the task load, the workload, the kind of tasks that are being executed by this operator or this train operator, whatever you want to call him, in GOR3-4, this remote control operator. So you can manipulate the workload towards a higher and more intermediate, a more optimal level. Yeah, and by raising the workload towards out of the underload spectrum towards more optimal levels, you actually reduce fatigue. This is what we could show, and also proposedly raise performance by that. Thanks. Next slide, please. So basically, in summary, I think taking into account the human and organizational factors enabled us to come up with a holistic vision for how GOR3-4 service could actually work, taking into account more and more issues from the operational, economic, like approval context, to incorporate this into one evolving vision on how the service can be safe, efficient, and also, let's say, satisfying for the staff involved. So thank you very much for the opportunity to speak, and I'd like to introduce our next speaker. She's Clarisse, and she will guide us to the very interesting topic on change management and how this actually can be implemented. Thank you very much.
Good afternoon. Thank you very much, Niels. So my name is Clarissa Gesdavon and I work in the Human and Organizational Factors team at the agency. So now we can ask ourselves, how do we integrate human and organizational factors in change management to avoid the problems such as highlighted by Christian Muhl and Niels Brudenberger? Today, with my colleague Fabrizio Carpinelli, we will present you the Human and Organizational Factors Change Management Toolkit. The safety management system is one of the cornerstones of the safety regulatory framework that helps to ensure a high level of railway safety. All those operating the railway system, such as railway undertakings or infrastructure managers, bear full responsibility for the safety of the system, each for their own part, and the establishment of a properly functioning SMS is identified as the appropriate way to fulfill this responsibility. So the purpose of the SMS is then to ensure that the organization achieves its business objective in a safe manner and complies with all the safety obligations that apply to it. These safety obligations must always be fulfilled in today's ever-changing and complex railway environment. So change management process ensures that changes within an organization are adequately planned, implemented in accordance with EU requirements, monitored and adapted to help the organization achieve its business objectives. Most railway systems rely on human and organizational performance, and integrating human and organizational factors from the start of a change will help to achieve business, safety and operational goals more efficiently, but also with less error and better acceptance of the change by end users, as I think was clearly underlined with the previous two presentations. So from that start, we adapted from the aviation and we developed with the support of railway sector representatives, which I really want to thank because it was a very fruitful collaboration, a toolkit to propose a systematic and systemic approach to integrate human and organizational factors throughout the change management process. So adopting a structured approach enables the identification of hazards and the continuous management of risk related to an organization activity, with the aim of course, preventing accidents. This approach takes into account the shared risk at the interfaces with other actors of the railway system. So many railway undertakings between themselves, but also with infrastructure managers and entities in charge of maintenance, and all the other actors having a potential impact on the safe operation of the railway system. As you will see with the presentation of Marcus Aurelius, the toolkit was continuously reviewed in our task force meetings to take into consideration the feedback from tests and user experience of this toolkit. So this methodology should be applied from the start of a change, that is to say when the need for a change is identified, and users should be integrated from the very beginning with the aim to identifying the specific human and organizational factors topics that will be included in this management process. To increase efficiency, and it was one result of the test, this methodology can be carried out in parallel or using the same resources as the other activities for change management. That is to say existing documentation, meetings or workshops. So as you can see, this methodology is composed of 5 steps plus an HOF assurance process, as can be shown here. The step 1 is the initial human and organizational factors assessment. The aim of this step is to identify human and organizational factors topics, which requires to have a good understanding of the system, the organization, and the task, and of course, how the change will have an impact on this. The first step begins with gathering information then on the change in order to identify what will change, which actors will be impacted, and how they will be impacted. Even a small organizational or technical change can have impacts on human and organizational factors. This is why a very detailed definition of the system is needed to identify all interactions and detect human and organizational factors influences.
The second steps consist in identifying human and organizational factors goals. So from the identified topics, you will have the need to analyze these topics and analyze and prioritize human and organizational factors goals, which are objectives defined in order to manage the topics. So this step may also take into consideration user needs, as was clearly understood previously, because the HOF goals are here to support the performance. Step 3 consists in defining the HOF assurance activities to support the change. So here again, we will take into consideration user needs based on the analysis and definition of the previously defined goals and potential optimization from the previous step. The objectives are really to identify the HOF assurance activities and how they will be monitored. Step 4 consists in defining HOF assurance implementation. The objective is to follow up the implementation of the HOF assurance plan that was described previously. It first starts with the implementation of the activities decided in the HOF assurance plan and also the monitoring, including the efficiency of these activities. The results are then analyzed, which allows the activities to be reviewed when needed. And as you can see, the output of this phase will be to produce, if necessary, residual design recommendations, including training and procedures, and add them to the HOF assurance report and the HOF topic logs. Last but not least, step 5, which is the verification and improvement. The objective of this step is to verify the HOF recommendations throughout the implementation of the change process, depending on the scale and the type of the change. This phase will need the intervention of different stakeholders, such as designers and manufacturers. This phase will aim at checking that the efficiency of the recommendations meets really end users' needs during installation, operation, and maintenance. So here again, we will need end users' involvement. As you can see, the process is iterative, and end users are consistently involved in each step to better integrate human and organizational performance, strengths, and also weaknesses, and develop better acceptance from end user and stakeholders. Change management tool is proposed to help to put into practice this methodology. So this is the second Excel table. This tool will also be completed in an iterative manner, as you can see. This methodology can be used for any changes, from a small to a more complex change involving many subsystem changes, such as organizational change, IT change, or procedural change, as we will see. A thorough description of the desired change is needed, as it may be necessary to break it down and study the interaction in several separate parts that may not have been identified at first. So, it is iterative, and even a new thing can have another impact. So it really needs this focus all the time. So this includes different systems, subsystems, teams, and activities. In order to better understand what will change and how the system, its different parts, will be impacted in terms of human and organizational factors, specific attention should be paid to the different tasks impacted and the definition of future roles and tasks with an iterative review of them throughout the process. This is really a two-way approach. Not only will the change affect human and organizational factors, but how human and organizational factors also can affect the change and its implementation. So this is really why this methodology is iterative, and you can find the different steps within also the supportive Excel tool, as it can be shown here, and the reassessment of topics several times where necessary. So thank you very much. I will now give the floor to Fabrizio. We will explain you a bit the taxonomy and how it was organized.
Thank you. Next slide, please. So as you have understood, if you want to make a HOF assessment, you will have at a moment or another to ask questions, to wonder in group or alone. So what kind of questions are you wondering if you see this work situation with a train driver, but can also be a traffic control room regulator or even workers on tracks? So what are you thinking about? Are you thinking about working at night. So yes, work rhythm, monotony maybe, or maybe to pay attention, or even more, experiencing some fatigue. And should be also the case in, yeah, to be motivated, to have some motivation to make this kind of work. And also to have some skills, to have acquired some knowledge to make the operation safe or to have a good performance. And also, of course, to respect some instructions, to follow some steps according to the time, to the situation. And maybe taking care also to the design of things. You can see here in the environment, but there are also unseen things. But yeah, you can see some devices, and this is also very important to take care about the design of the things. Last but not least, you have also some communications which are really important, the key messages shared between operators and traffic control room, for example, and train drivers and so on. You have also the trust, which is also very important to make a rise between workers and the whole system, of course. As you can see, there are plenty of factors, and we have attempted to stabilize a set of factors based on the work of Kyriakides, for example, or the HFAX, a series of nanocodes, and we have stabilized two HASs. As you can see now, next please, you have a dynamic part opposed to the static part, and you have also on the left situational part, and on the right the staff part. And if you consider this as 5 categories, you will have those names, for example. Yes, next. So you have on the top left the dynamic situational categories, and you have shortlisted some factors most commonly found with in railway accident, for example, about pressure, complexity, monotony, work rhythms, environments. You have also on the top right the dynamic part concerning staff, so with intentions, attention, awareness, fatigue, stress. The bottom right, always still concerning staff. You have the static part, experience, personal, motivation, skills, decision making, and you have also on the bottom left, static situational with communication means, instructions, tools, design, context, and at the very center being all static dynamics based on the situation, but also on staff, of course, you have the social interactional factors made with communications, relation, trust, reinforcement, involvement. So we have not only listed those factors, we have also emphasized on those interactions, and those interactions are exemplified by this slide with creating or updating procedures. For example, thanks to those categories, you can visualize and anticipate and of course, raise question about those interactions. So, for example, starting with instructions revised, you will make the links towards intentions, explaining how errors can arise, for example, applying those instructions or the steps during instructions, making some shortcut to avoid errors, or which kind of points you should pay more attention for that, being aware of something else. This is also normally for the designer of the instructions to pay attention to the complexity. Is those instructions reducing complexity or increasing complexity? The design should also include some steps to involve end users, and this will emphasize and make trust even more high. And of course, design should also let a clear decision-making steps for the users. So last but not least, for each of these factors, we have, with the task force, we have also designed this tool, preparing some basic questions for each factor. So each 5 by 5, for each 25 factors, we have a series of questions prepared to let the group or the individual working on this risk assessment dedicated to this change ask those questions and searching for answers. And this is it. Thank you, Clarisse.
Thank you very much, Fabrizio. So for the next steps, the publication should be by end of 2022 of further guidance document, which has two parts, the methodology and the guidance on how to use the HOF change management tool that I showed. But also the HOF management tool, which is composed today of 2 Excel tables. And we are currently developing the training materials. So you can have more information by clicking on the, by sending us an email, we can tell you. And I would like really to benefit from this webinar to thank the task force and all the members that were very reactive, creative, and that helped us to develop and test and improve this toolkit. So thank you very much, and especially I will now leave the floor to one of them, who is Marcus Arrhenius, that tested the toolkit and helped us improve it. Thank you very much.
Thank you, Clarisse, and thank you for the transition. So my presentation will focus on the test of the tool. We conducted a test here at DZSF AG, and for a change to a communication process. And for this, we use the described methodology and the HOF toolkit, so the Excel tool that was also shortly described in the presentation before. So next slide, please. Okay, Cyril, you can just move through quite quickly through here the current state. So what is the change that we considered for the toolkit? This change consists of the introduction of a new IT software to change a communication process. So the current state looks as follows. Just press the buttons. If there is a disturbance, for instance here a faulty signal, then after the fulfillment of the operational requirements, command can be sent to the train driver. For this to happen, the signaler contacts the train driver via a telephone to, among other things, communicate the intention. And the signaler then transmits the relevant information for the command to the train driver. So, for instance, the location of the train and which kind of command that should be used and the content of the command. So this is dictated verbally. And then the train driver receives this information and verbally repeats the information in order to ensure that a correct understanding is given and that the command is correct, so to speak. So what will be changed? So the target state that is currently envisioned, and this is still a very early change or a very early phase of the change, would be that the train driver is informed that a command is coming via a software, and that the information that was in the standard process in the current state is dictated, that this is received via an app, and that the train driver checks the app and the information of the command in the app and confirms the correct information, to speak. Okay, next slide, please. So this was the change we applied the toolkit and the methodology to. We had 2 sessions at 2 hours each, in which we applied the toolkit. The participants consisted of 1 project manager, one user expert and a moderator. And for this test, it was very important to us that the moderator should not have a very deep expert understanding of HOF subjects and topics in order to ensure that the toolkit can also be used by users that do not have very deep HOF knowledge. So what were the existing strengths of the application of this tool? The participants greatly appreciated the questions that detail the 5x5 factors that Fabrizio presented earlier. So for every factor, like for existence fatigue, there are different questions that detail what fatigue means and how it could affect the change. And this was something that was very much appreciated by the participants, especially since the general description of the factors, although it's very good for HOF experts, requires some more guiding and leading the non-HOF experts to the right question, so to speak. And this was especially true for softer and organizational factors. So next, please. They also very much appreciated the filter or screening logic that is embedded in the tool, so that you move from more general factors into more detailed questions and factors. And this helps in focusing the tool application so that you mainly consider those factors that are really relevant for your change. Okay, next, please. And they also really appreciated the automatic support highlighting of important decisions that is done by the Excel tool. So what were some areas of improvement then? Next, please. One area of improvement is the time requirement that mainly came from redundancy with existing processes. So one of the steps in applying the toolkit is to identify stakeholder needs and goals in order to evaluate those goals against each other and towards the change. And this is something that is already implemented in some of the processes at DZSF AG. So this input can be, if it is known, can be taken into the HOF assessment and can greatly facilitate this step. There is also redundancy to other topics, for instance, the risk assessment, where we already had a system definition, and this was something that we also took into the tool application and could use in order to focus the analysis. Another question was if the toolkit should be applied for certain tasks. We heard from Niels, for example, that task analysis is one of the most crucial steps in the HOF assessment. And here our recommendation would be not to focus the analysis on specific activities, but the complete change, since this facilitates the evaluation. And next point, please. And this is something that's, I think, very important. There are some human factors concepts in the tool that are not immediately accessible to the standard user that don't have a deep HOF knowledge. For instance, regarding trust in automation and degrees of automation, as we saw in Christine's presentation, for instance, degrees of automation can be different depending on which framework you apply. So our recommendation here was to, next point, please, to improve the description and add these concepts to the training material. And that would be the main points. Thank you.
Okay, thank you very much, everybody, for the very interesting presentations. We have some questions in that the public have asked. The first one is for you, Niels. Is there a driver on train when having those centralized teams?
Yeah, thanks a lot, Jane, for the question. I think the question is a good example on that there is no quick answer to these kind of questions, but you have to take into account several aspects. On the one hand, it differentiates between what kind of service you're running, probably. It impacts whether you're doing a passenger or freight operation. Yeah, then it might also come down to whether it's long distance, like a high-speed long distance line, or whether it's rather an urban operation. Yeah, so probably you could argue that on a long-range train journey with passenger operations, there is likely to be a train attendant on board anyway. So, of course, you could think about like roles that incorporate for some scenarios also the engagement of the train attendant, for example. Yeah, I think in the end, it's a balance between, as I also mentioned in my talk earlier, it's a balance between operational like aspects, considerations, like what is possible operationally from the process. Can we handle this without somebody there? It's about the user trust. Yeah, what is also acknowledged by the users, the passengers. We just have to see what the acceptance level is. It's about the economics, like how expensive is it to realize a certain functionality for a certain scenario with and without somebody on board. Yeah, and then there's also the reliability issue, like how, if in case we don't have somebody on board, for example, in an evacuation case, which is absolutely critical, we have to think about how reliable is our solution without somebody on board. Is this reliable enough? And this is something for the authorities to decide in the end. So it's a mixed answer. I think probably for some operations, you won't have one on board, especially urban and freight, medium range, this kind of operation. When it comes to high-speed passenger operations, where also a lot of passengers are on board, which is also one issue for risk analysis, people to value very high, then you might get back to the train attendant or even remain with the train driver as a safety level. But in general, I'd rather argue that probably it's going to there's nobody on board. This will be my answer.
Great. Thanks very much for that, Niels. We have another question, this time for Kristen. Okay, the DMI supports situational awareness. However, it is a matter of monitoring information and therefore moving from being an actor to monitor. Humans are not good at monitoring. Wouldn't it be better to drop the GOA2 or automate everything?
Okay, thank you, Jane, for the question. I think this is a question which comes along quite often. I think Niels totally understands me with that. So yes, this is correct. It supports situational awareness, but I also totally agree that the train driver is still or has to monitor the whole time, and we are not good at monitoring. This is definitely correct. And if we are looking at some data, for example, statistics or analysis that Niels, for example, made, he has shown before, then we can see that performance decreases, workload decreases, which seems to be good, but it could also go in underload, and fatigue increases, so with the GOA2 or under GOA2. So actually, with regard to the human and human factors, the GOA2 is not the best case for the human. And if we are taking a closer look also in the statistics or in the results, that we can see that with the GOA3 or even GOA4, this would actually be better for the human. But the question is whether we can automate or have a GOA level 3 or 4 everywhere, and it's going to be much more complex in some aspects. So it's quite easy to automate or to have some kind of autonomous metro lines, because there we have the great infrastructure for everything. But for the mainline train, it looks quite different. And I mean, there are great research projects going on to really transform this. But we always need to keep in mind, I think, this job of the train driver will change We will have a change on that, but I think there will be any kind of train drivers, like remote train drivers, even with GOA 4. And there we will also have the problem with monitoring. So we definitely need to take a closer look on this task, how we can design this task to make it as easy and appropriate for the driver or for the operator that it's fine for the human. We definitely need to keep that in mind. Okay, I think Jane is gone now.
Okay. Thank you very much, Kristen, for that. We have another question. Asking, this is for Clarice and Fabrizio, and that is, I haven't received that one. Sorry. Okay, in the meantime. Okay, sorry. Automated systems. Okay, this is for Clarice and Fabrizio. What needs to be documented to prove that our organization complies with Chapter 4.6 on human organizational factors of the Regulation 762? Can you give examples, please?
Yes, thank you, Jane, for the question. You will find examples and practical evidence within the SMS guidance. It was reviewed last year to really emphasize more what is expected concerning human and organizational factors and safety culture, which are two topics that were introduced in the fourth railway package. So, of course, you have the human and organizational factor strategy, which is a requirement from the CSM on SMS. And from that, we will assess that there is really a systematic approach within the SMS processes and procedures to human and organizational factors. So everybody use human and organizational factors throughout the SMS, but really the emphasis is on the evidence that can be given for that. For example, for risk assessment, how do you integrate human and organizational factors and users from task analysis, and then how you will integrate it in your procedures for a specific risk. Then for this specific risk, how will you give information for end users, such as in training, such as in the procedures itself, to have a very clear explanation of what is needed, what needs to be analyzed, and how the decision is taken. But these are just examples that, if you read carefully the guidance on SMS, you will find many more examples and help to identify those.
Okay, I have another question for Clarice and Fabrizio on the toolkit. How would you expect the toolkit to be applied in combination with the CSM, the Common Safety Method, on risk assessment for significant changes?
It is a combination, that is to say, the toolkit aims at identifying the human and organizational factors topics. That is to say, when you will assess the risk and put into practice the CSM on risk assessment, with the help of the toolkit, you will be able to identify more easily and more carefully, more systematically, the human and organizational factors topics. I don't know if Fabrizio, you want to complement?
Yes, I will just add. Yes, thank you. I will just add that in this new CSM On the SLP, for example, there is already the list of the 5x5 factors to be referred to. So I think that this can be a good point to start from. Yes. Thank you.
Okay, we have another one for, this is it's a question to both Marcus and Niels. Does the starting point of application of the HOF toolkit by relatively, on the topic of HOF assures good application of HOF insights, that at the end results in good design of a rail system with a higher degree of automation? I'm not quite sure what that, I'm not quite sure what that question. I don't know if either of you would like to take that.
Well, I can speak from our experience in applying the toolkit to the change that we had, and Christine would add, I guess. Our experience was that by applying the toolkit, you more systematically get to the points where you have to address, for instance, how the user systematically handles errors in automation, breakdowns in automation, and how to ensure that if the user then has to take over functions, for instance, how they can remain do this with a high reliability, so to speak. That was for us one of the main points from the tool. On the one hand, to systematically go through the exchange between technical errors and how the human compensates and how this is integrated in the change. And on the other hand, how the change itself, by automating certain tasks, switches the roles of the users to, for instance, detecting issues and errors in the automation, and here in the app that transmits the information. So this is something that in the tool application was very evident, and something that I think the tool supported very good in the application.
Christine, you can take the floor if you want to complement on that.
Thank you. Actually, not now. No, Marcus did a good job.
Niels, would you like to complement on that? I think you do.
Actually, not on the question that Mark just answered, but I'm seeing a different one still. Reading out, the DMI is not used for monitoring, but it's a human interface providing, human machine interface, I guess, providing the driver with the necessary driving information. The driver still runs the train. This is what I'm reading. And I can only say, okay, that's very much true indeed. And I just want to point out, maybe if there's some unclarity about this, I'd just like to point out that irregardless of any GOR level, whether it's currently GOR 1, intermediate GOR 2, or GOR 3, 4, once you control or drive a certain train, the DMI is the central information interface that you will be using for controlling the train, so that what is pointed out in the statement is absolutely true indeed. And the monitoring aspect, yeah, of course, you also have to monitor the DMI, but the monitoring also very much includes the technical displays. Used to be on the left. I think with most locomotives it's still on the left. So the technical display is also very much included in the monitoring. So yeah, the DMI is more than just a monitoring interface. It provides you with all the necessary control information as well.
I would like to add on that. On this question, of course, I'm totally with that. Sorry if it was wrong or came wrong. The driver still runs the train, but as I explained, we have different frameworks of grades of automation, and the other framework I mentioned was on human information processing. And here we have a higher level of of automation with regard to the human information processing on information analysis and information acquisition, not on action implementation, which would be train driving. This is what I wanted to show, that GOA level have a focus on operation, but not on human information processing. But if we want to take a closer look on the driver, on the human, then we also need to take a closer look on the information processing and the levels of automation with regard to that. And so maybe there was a kind of disruption, or kind of not disruption, it was not clear like that. Okay, I hope we are fine now.
Okay, that's all the time we have for questions, but I'd like to take this opportunity to thank all the presenters. I think the case for busting the automation myths has been made. The conclusions being that we still need the human in the system. And in order for automation to reach its potential, we have to take human and organizational factors into account. And I'd like to thank my colleagues, Clarice and Fabrizio, for very clearly explaining the toolkit, and Marcus for giving feedback on how it actually functions in a real life case. So I'd like to thank you very much for attending, and I'll pass you over to my colleague, Cyril. Thank you.
Thanks a lot, Jane. And indeed, we are now reaching the end of this webinar. First, let me thank on my turn warmly all of the speakers and all of the colleagues involved in the preparation of this event. I want to thank them not only for their contribution, but also for their enthusiasm and their support. Thank you, for dear attendees, for your attendance, participation. And before you go, we will be very happy to receive your feedback on this webinar via the link provided on the webinar webpage on the ERA website, or via the QR code that you're seeing right now on the screen and that you can flash with your smartphone. We look forward to meeting you again at our upcoming webinar on the 30th of June about railway safety and interoperability, the importance of data sharing. The report has just been published on the website. And before that, I'd like to draw your attention on an important physical event that ERA is organizing next week in Le Havre in France, jointly with Aropaport, the Multimodal Freight Conference. If you're interested, please check the ERA website and register. There are still some seats available. We would be very happy to meet you there. In the meantime, if you would like to stay updated on our activities, please sign into our database by selecting the button Logging on our website page. Thank you very much for participating. We wish you a very pleasant afternoon. Take care.